Welcome to MindTier Learning, where we make GCSE learning and revision simple. In today's GCSE Maths lesson, we're introducing linear graphs. Linear graphs are straight line graphs, and they are one of the most important graph types in GCSE Maths. They help us show relationships between two variables, such as cost and time, distance and speed, or hours worked and money earned. By the end of this lesson, you will understand how to plot coordinates, create a table of values, recognize the equation y equals mx plus c, and check whether a point lies on a line. Before we begin, remember to like this video, subscribe to MindTier Learning, and follow along carefully. By the end of this lesson, you should be able to plot coordinates across all four quadrants. You will learn how to generate a table of values for linear functions. You will recognize the general form y equals mx plus c. Finally, you will draw straight line graphs and check whether specific points lie on them. These skills are important because linear graphs appear in algebra, real-life graphs, coordinate geometry, and problem-solving questions. Let's begin with the key vocabulary. Linear means a relationship between two variables that produces a straight line when graphed. A coordinate is a pair of numbers, written as x, y, that gives the exact position of a point on a grid. The gradient is a measure of the steepness of a line. In the equation y equals mx plus c, the gradient is represented by m. An intercept is the point where the graph crosses an axis. In this lesson, we will mostly focus on the y-intercept. What do mobile phone contracts, taxi fares, and skyscraper shadows have in common? They can all be modelled using linear equations. That means if we know the rule, we can make predictions. For example, if a taxi fare has a fixed starting charge and then increases by the same amount for every mile, that relationship can be shown with a straight line graph. Before we build those lines, we need to make sure we can use the coordinate grid confidently. Let's recap the four quadrants. Coordinates are written as x, y. A helpful phrase is along the corridor, then up or down the stairs. That means we move along the x-axis first, then up or down on the y-axis. In quadrant 1, both values are positive. In quadrant 2, x is negative and y is positive. In quadrant 3, both values are negative. In quadrant 4, x is positive and y is negative. Knowing the signs helps us plot points accurately. Now, let's try a coordinate challenge. You need to match each quadrant to the correct position. Quadrant 1 has positive x and positive y. Quadrant 2 has negative x and positive y. Quadrant 3 has negative x and negative y. Quadrant 4 has positive x and negative y. Pause the video and match each quadrant before checking the answers. Let's check the answers. Quadrant 1, where both x and y are positive, matches D. Quadrant 2, where x is negative and y is positive, matches C. Quadrant 3, where both x and y are negative, matches A. Quadrant 4, where x is positive and y is negative, matches B. This is useful because when plotting coordinates, the signs tell you which section of the grid to use. Now, let's look at the most important form for straight line graphs. Almost every straight line can be written in the form y equals mx plus c. Here, y is the output, or vertical position. X is the input, or horizontal position. M is the gradient, which tells us the steepness of the line. C is the y-intercept, which tells us where the line crosses the y-axis. A useful rule to remember is this. If there is no x squared or x cubed, the graph will be a straight line. To draw a graph like y equals 2x plus 1, we first calculate some coordinates. We do this using a table of values. Choose some x values, such as negative 1, 0, 1, and 2. Then, substitute each x value into the equation. If x equals -1, y equals 2 times -1 plus 1. That gives -2 plus 1, which is -1. So one coordinate is -1, -1. If x equals 0, y equals 2 times 0 plus 1, which is 1. So another coordinate is 0, 1. If x equals 1, y equals 2 times 1 plus 1, which is 3. So the coordinate is 1, 3. If x equals 2, y equals 2 times 2 plus 1, which is 5. So the coordinate is 2, 5. Once we have our coordinates, we plot them carefully on the grid. For the equation y equals 2x plus 1, we can plot the points. -1, -1, 0, 1, 1, 3, and 2, 5. Use a sharp pencil and plot each point as accurately as possible. Then use a ruler to draw one straight line through the points. Here is the golden rule. If your points do not form a straight line, something has gone wrong. Go back and check your table of values and your plotting. Let's check your understanding. In the equation y equals 3x minus 2, the number 3 represents the blank and -2 represents the blank. To find a point on the line, we substitute an x value into the blank. Use the word bank to complete the sentence. Pause the video and have a go before checking the answer. The completed sentence is, in the equation y equals 3x minus 2, the number 3 represents the gradient and -2 represents the intercept. To find a point on the line, we substitute an x value into the equation. This links the equation to the graph. The gradient tells us how steep the line is, and the intercept tells us where it starts on the y-axis. You do not always need to draw a graph to check whether a point lies on a line. You can use substitution. For example, for the line y equals 4, x minus 3, does the point 2, 5, lie on it? The x value is 2, so substitute x equals 2 into the equation. 4 times 2 minus 3 equals 8 minus 3, which equals 5. The y value we calculated is 5, and the coordinate also has y equals 5. So the point 2, 5 does lie on the line. Now, let's try a substitution challenge. The statement says, the point 3, 10 lies on the line y equals 2x plus 5. Is that true or false? Pause the video and check it by substituting x equals 3 into the equation. Then compare your calculated y value with the y coordinate in the point. The statement is false. When x equals 3, the equation gives y equals 2 times 3 plus 5. 2 times 3 is 6. 6 plus 5 is 11. So when x is 3, y should be 11, not 10. That means the point 3. 10 does not lie on the line y equals 2x plus 5. The correct explanation is when x equals 3, y equals 2 times 3 plus 5, which equals 11, not 10. This shows that the point is not on the line. To lie on the line, both the x value and y value must satisfy the equation. Now, let's apply linear graphs to a real-world example. Imagine a plumber charges £50 just to turn up to your house, and then £30 for every hour they work. How could we represent this as a linear equation in the form y equals mx plus c? Think about what the starting cost is and what increases each hour. Pause the video and try writing the equation. You might have said, the equation is y equals 30x plus 50. Here, y is the total cost, and x is the number of hours worked. The y-intercept is 50 because that is the starting cost before any hours are worked. The gradient is 30 because the cost increases by £30 for every extra hour. On a graph, this would be a straight line starting at 50 on the y-axis and rising by 30 for every 1 hour across. Let's finish with a final review task. Take the equation, y equals -x plus 4. You have 3 challenges. Step 1. create a table of values for x equals -2, 0, and 2. Let's calculate them. If x equals -2, y equals -2 plus 4, which is 2 plus 4, so y equals 6. If x equals 0, y equals -0 plus 4, so y equals 4. If x equals 2, y equals -2 plus 4, so y equals 2. So the points are -2, 6, 0, 4, and 2, 2. Step 2. Plot those 3 points and connect them with a straight line. Step 3. Check whether the point 5, -1, lies on the line. Substitute x equals 5 into the equation. Y equals -5 plus 4, which equals -1. So yes, the point 5, -1, lies on the line. You should now be able to plot coordinates in all 4 quadrants, create a table of values, recognize y equals mx plus c, draw straight line graphs, and check whether a point lies on a line. Remember, a linear graph is a straight line, and every point on that line must satisfy the equation. If this lesson helped, please like the video, subscribe to MindTier Learning, and watch the next GCSE Maths lesson to keep building your graph skills.